Hi, in this video we are going to talk about depth-first search, the other most important graph traversal algorithm besides breadth-first search. So let's get started. So what is DFS? Depth-first search is a widely used graph traversal algorithm, as I said earlier. It explores as far as possible along each branch before backtracking. So it doesn't need pointers, unlike breadth-first search, and this is the main advantage of DFS over BFS. So it is very memory friendly, and the time complexity of traversing a graph with DFS is the same as for BFS. So it has a time complexity ordo V plus C, where V denotes the number of vertices and E denotes the number of edges in our graph. It has several applications, for example topological ordering or Kosharayu algorithm or detecting cycles. If you are familiar with graph algorithms, I mean the theoretical background of the graph algorithms, topological ordering can be applied to detect the order in which, for example, the operating system organizes the processes. The Kosharayu algorithm is a very efficient, maybe it's not as efficient as Tarian algorithm, but it can construct if we have a graph and if it's strongly connected, which means that we can get from any vertex to any other vertex, we can detect these strongly connected components with the help of Kosharayu algorithm. And detecting cycles, it's very important. A directed acyclic graph doesn't have any cycles, and we can detect these kinds of cycles in linear time with the help of depth-first search. So how does it look? We have the same graph as for breadth-first search, and if you may recall, breadth-first search goes from layer to layer as deep as possible in the end, and depth-first search does not the same. So we keep going and keep going as deep as we can. And after reaching the last item, I mean the deepest item, we keep backtracking and go back to 4. We try to visit its right child, but it doesn't have any right child. So we backtrack to node 2 and we try to visit its right child, and it has a right child, so we visit it. We backtrack to the root and try to visit its right child. It has a right child, so we visit it. So it's kind of let's go as deep as possible and then backtracking and backtracking and backtracking. So that's the main difference between depth-first search and depth-first search. And advanced algorithms such as A-star search or iterative depth-first search tries to combine the advantages of both of these graph traversal algorithms. So that's all about DFS. Thanks for watching.